In 2.2, we're going to be discussing subsets. Now, if you take a look at this real number set that we have listed in front of us, you can see that if you start in the middle, we ended up initially with our natural numbers, which include 1, 2, 3, dot, dot, dot. Natural numbers are included within the whole numbers. Whole numbers are included inside of the integers. Integers included in the rational number set. So these are considered subsets. When something is contained within another set, it's considered a subset. All right, rational numbers here is a subset to the real numbers. Irrational numbers also is a subset of the real numbers. We'll discuss this further as we go through each slide and practice. So here is our first definition. Set A is a subset of set B if every element in set A is also an element in set B. All right, and the symbol you're going to use looks like the letter C with a little line below it. And that means set A is a subset of set B. So if we wanted to think of an example, I could say, let's make set A have the following items, 2, 3, 4. And we'll say set B will contain this list of numbers, 0, 1, 2, 3. So in this case here, I can say set A is a subset of set B because every element in set A is contained in set B. This is the definition of subset. Example 1, using the symbols. So the first one means subset, a subset of, and then the other one with the slash through it means is not a subset. All right, so it says write subset or not a subset in each blank to form a true statement. So for part A, they give us two sets. Set A is 1, 3, 5, 7. Set B is 1, 3, 5, 7, 9, 11. They want us to compare set A to set B, and you can see that every element in set A is also contained in set B. So A is a subset of B. Part B, the first set is X such that X is a letter of the word proof. And B, set B is Y is such that Y is a letter in the word roof. All right, when you were thinking about this, maybe you can write this out in roster method if you'd like to. And if we did that, we would have set A, we have a P, an R, an O, and an F. Remember, I don't need to write the repeated on there. And set B, R, O, and F. So if you take a look at these, every element in A is not contained in B. So we would say that these are not, A is not a subset of set B. All right, and part C, A is such that X is a planet of the Earth's solar system, and B is Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. All right, and in this case here, set A is contained, so therefore it is a subset of set B. Select subset or not a subset for the blank so that the resulting statement is true. So we need to compare our two sets. We want to know if this first set that contains -3, 0, 3 is a subset or not a subset to the second set, which contains negative 3, negative 1, 1, and 3. So we can identify quite easily that negative 3 from the first set is contained in the second set, and the 3 from the first set is also contained in the second set. However, we are missing the 0 from the first set, which does not exist in the second set. So therefore, we're going to say that the first set is not a subset of the second set. Select subset or not a subset for the blank so that the resulting statement is true. So you want to be careful when you take a look at these fractions. The first set says 6 over 2 and 9 over 13. And you want to take a look and see if those two fractions are contained in the second set, which they are not. So the answer on here would be that the first one is not a subset of the second set. All right, so the second set actually contains the reciprocals of the first set, but it does not contain the exact original elements from the first set. So we have been practicing a subset of a set. That is when every element in the first set is contained in the second set or included in the second set. Now we have what's called a proper subset of a set. And the definition for that is set A is considered a proper subset of set B. And this is expressed with just that C-looking item symbol. And it says A is a proper subset of B if A is a subset to B and sets A and B are not equal. So there's two conditions on there to be a proper subset. A has to be a subset of B, and A and B cannot be equal. So let's take a look at example 2 here. It says write subset, proper subset, or both in each blank to form a true statement. Part A says X such that X is a person and X lives in San Francisco. Set B says X such that X is a person and X lives in California. So set A, if a person lives in San Francisco, is that person also contained in California of set B? The answer is yes. So for the first one, we know that A is a subset of B. So we know that we have A is a subset of B. The second thing you need to look at for this first problem is, are these two sets exactly the same? Are they equal? Remember the definition for equal sets. Regardless of order or repetition, they have to have the same elements. So is living in San Francisco the same thing exactly living in California? So San Francisco is not equal to California. San Francisco is just a city. It's limited to a city. All right. So these are not equal. So therefore, I can also say that set A is a proper subset of B. So we can actually use both of those symbols for part A. For part B, we have set A is 2, 4, 6, 8. Set B, 2, 8, 4, 6. All right. And then we're going to ask ourselves, is set A a subset of set B? All right. So each element in set A is contained in set B. So therefore, I can say set A is a subset of set B. All the elements in A are contained in set B. And then because these are identical, because A is equal to B, right? Because they're equal, we cannot say that they are a proper subset, that A definitely would be not a proper subset of B. So the only item I could use on this one would be that it is a subset, not a proper subset. All right, determine whether subset, proper subset, both or neither can be placed in the blank to make the statement true. So the first set, and I'm going to call this set A here, contains 2, 6, 10, 14, 18. And I'll say the second one is set B, contains 6, 18, 2, 14, 10. Every element in the first set is contained in the second set. So what I do know is A is a subset of B. And then if for it to satisfy the conditions for proper subset, A has to be a subset of B and A cannot be equal to B. So I'll write this out. Since A is equal to B, every element in A is exactly the same as the elements in set B. Since A is equal to B, the sets are not proper subset. The set A is not a proper subset of set B. So if you recall, in order to be a proper subset, let me write this out. Two conditions, is that A must be a subset of B and A cannot equal to B for it to be a proper subset. Determine whether subset, proper subset, both or neither can be placed in the blank to form a true statement. Set A is a set of natural numbers, or set of all x's such that x is a natural number and 4 is less than x, which is less than 8. So let's place this one into roster notation. So it has to be a natural number, and x is in between 4 and 8. We do not see the less than or equal to sign, so we cannot use 4 and 8. So I will list 5, 6, and 7. Set B is a set of all natural numbers between 2 and 9. Set B is a set of natural numbers in between 2 and 9. So it says in between means we cannot include 2 and 9. So this is 3, 4, 5, 6, 7, 8. All right, so let's check the first condition. Is A subset of B? So every element in A is contained in set B. So therefore, A is a subset of B. Now we want to check to see if it is a proper subset. For it to be a proper subset, our first condition has been met right here. The second condition we want to check for is A not equal to B. All right, and when you take a look at that, you can see that set A is not equal to B. That's a true statement. So since the A is not equal to B, and A is a subset of B, therefore, these are considered a proper subset. A is a proper subset of B. So in this condition here, we're going to choose option C because A is a subset and A is a proper subset of B. As we continue to practice, what you need to do is continue to remember your definitions of subset versus proper subset. All right, so this one says determine whether the given statement is true or false. So this is saying the first set containing A is a subset of the second set containing 8, 6, 5, 7. And is this a true statement? Yes, it is. The element 5 is contained in the second set. So therefore, the first set is a subset to the second set. All the symbols used in set theory make me feel that I'm an element of the set of the notationally confused. For example, what's the difference between these two symbols? All right, so we know the funny looking E means is an element of, and the C with the line under it means is a subset of. It says, notice the difference among the following true statements. So they're already saying that these are true statements. 4 is an element of this set containing 4, 8. So that is a true statement because 4 is indeed an element of that set. The second option here is saying that the set containing 4 is a subset of the set containing 4, 8. So 4 is contained in the second set. So therefore, the first set is a subset towards the second set. Lastly, it says the set containing 4 is not an element of the set containing 4, 8. If you want to consider it to be an element of, you would have to have the set 4 for it to be an element. It would actually have to be rewritten as the first set containing inside the second set. Then we can say it's an element. The empty set as a subset. So here's another definition for you. It says if for any set B, it says the empty set or null set is a subset for B. For any set other than the empty set, for any set B other than the empty set is a proper subset of B. So let's take a look at example 3, see if we can make some sense of this definition. It says let A equal to the empty set. There's set A. And set B is 1, 2, 3, 4, 5. The question, is A subset of B? So they're asking you, is the empty set, because that's what that is the empty set a subset of B? The answer is yes. All right, and the reason why it is yes is there are no elements in set A that are not contained in set B. And the solution region here will explain that to you. It says we cannot find an element in the empty set that is not contained in B. So therefore, that means that A is a subset of B, which supports the definition of the empty set is a subset. To help you find the number of subsets that some sets contain, we have some formulas. In this case here, let's just look at the table. It says the empty set, I'm looking at this very first one, the empty set here has 0 elements, right? So since it has 0 elements, and it says you want to list all the distinct subsets, well, the empty set is just the empty set. So there is only one subset. If we do this enough, we'll see a pattern on there. All right, the set containing A contains exactly 1 element. The distinct subsets for that set is, it can be set containing A or it can be the empty set. So this one has 2 subsets. The set containing AB has exactly 2 elements. So the options for distinct subsets would be the set containing AB, the set containing A, the set containing B, or the empty set. Notice there are 4 subsets here. And then again, if you have 3 elements, you end up with a total of 8 subsets, and you can list each one. All right, so to find out the number of subsets that you have, you're going to use 2 to the n power. All right, n is the number of elements, 2 to the n power. So on this first one, we had 0 elements here. So 2 to the 0 power, that's going to give you 1. So that tells you and confirms that we had one subset. For the second option, it had one element, so 2 to the first power is going to give you 2, which matches right here that we have 2 subsets. Now we can keep going on. 2 to the second power is equal to 4, which matches right here that we have 4 subsets. So if you need to find out how many subsets you could possibly write down, you always use 2 to the nth power. Now let's do that last one. 2 to the third power is 8, which matches 8 subsets. All right, if you're looking, now this is just for subsets. If you're looking for the proper subsets, remember the condition for proper subset. It says the first one is the first set must be a subset of the second set. The second condition is that they cannot be equal. So if they are equal, what we have to do is use this subtract 1. Let's say 2 to the n. This minus 1 is subtracting the one set where they're equal. All right, so if you take a look at this bottom, this very last set, right here where it says set ABC, we would subtract the set ABC, that one set, so that we can create proper subsets, because we don't want them to be equal. All right, so once again on the bottom here it says proper subsets do not include the original set. Thus, that's going to make up for that subtract 1. For example 4, it says, find the number of distinct subsets and the number of distinct proper subsets for each set. So we're taking a look at part A, and it has A, B, C, D, E. So if I count each one of these, I have 5 elements. All right, because I have 5 elements, I'm going to take 2 to the 5th power, and I'll place that in my handy dandy calculator, and I'll get 32 subsets. Remember, the 5 is the number of elements that you have. So I have 32 subsets. Now, if I take the 2 to the 5th power and subtract 1, I am going to get 32 minus 1, or 31 proper subsets. So to find the number of subsets and the number of proper subsets, we need to know how many elements will be contained in that set. If we look at part B, x such that x is an element of the natural number, and n is, and we have that 9 is less than or equal to x, which is less than or equal to 15. So that means we include the 9 and the 15. So let me just write this out real quick. So 9, 12, 13, 14, and we'll include 15 also. So if you count this, we have 7 elements. So 7 would be the n, if you will. So 2 to the 7th power is going to give you 128 subsets. And if I say 2 to the 7th power minus 1, we're going to get 128 minus 1, or 127 proper subsets. So it does matter if you're looking for subsets or proper subsets. Remember, proper subsets do not include the original set, so therefore it would be subtract 1. For the given set, first calculate the number of subsets for the set, then calculate the number of proper subsets. So again, we're going to take a look at our set and count how many elements we have. And we have 1, 2, 3, 4, 5. So we have 5 elements. Remember, that's going to be 2 to the n for our subsets, and 2 to the n power minus 1 for our proper subsets. All right, so since we have 5 elements, again, this is 2 to the 5th power, or 32 subsets. And 2 to the 5th power minus 1. Going to give us 31 proper subsets. Right, those final answers here would be 32 and 31. Determine whether the following statement is true or false. If the statement is false, make the necessary change or changes to produce a true statement. All right, so we have the first set, which says x is a natural number and 100 is less than x, which is less than 140. And they're saying that this is a subset of the second set. Second set is x is a natural number and 100 is less than or equal to x, which is less than or equal to 140. So what we can do is take a look at these items in roster notation if you'd like. So since the first one is the natural numbers, where x is between 100 and 149, we would look at 101, 102, 3, and I'm going to put an ellipse there. And remember, it's going to go up to 139 because it's less than 140. So that is the roster method for the first one. So we want to know if this will give us a true statement if we say this first set is a subset of the second set. Now, taking a look at the second set, we have that it is less than or equal to. So that means we can include the number 100. I'll write a couple of numbers here. And it is less than or equal to 140. All right, so we want to know if the first set is contained, the elements in the first set are contained in as elements in the second set. And you can see that it does. Every element in the first set is included in the second set. So therefore, this is considered a true statement. We can make sets in a variety of ways, and we can take the elements in the sets and create different situations. So this is a great example of one using money. It says, suppose that a nickel, a dime, and a quarter are on the table. You may select some, all, or none of the coins. All right, so what they're asking you to do is to select which ones of these are you able to create. Remember, you only have one of each item. So a dime is 10 cents, so we can create the 10 cents. Can we create 40 cents? Sure we can. We have the quarter plus the nickel plus the dime will give us 40. 25 cents would be the quarter. 15 cents would be the nickel and dime. So what we're doing is seeing which ones we can add together to create this certain amount of money. 20 cents, I cannot create 20 cents. So that one I'm not going to look at. 5 cents would be just the nickel. 0 cents, remember it said we could select none. So that one works. 26 cents, I don't have a penny, so I cannot do that one. 16 cents, we cannot do again. We need the penny to do that. 30 cents you can create with the quarter and the nickel. 36 cents, no. 41 cents, no. Again, we still need that penny. 35 cents, the quarter and the dime. 11 cents, no. 21 cents, no. And the 6 sense? No. All right, so what we're actually doing is a part of set theory. Essentially, what we found are the subsets for this description. We have 3 coins, so we would have 3 elements. So 2 to the third power give you 8 subsets. So we found these subsets. And if you count all of these, 1, 2, 3, 4, 5, 6, 7, we were able to find all 8 subsets. Amber wants to visit Philadelphia, Chicago, Austin, Charlotte, San Jose, Los Angeles, New York, Detroit, Seattle, Memphis, and Jacksonville. If she decides to visit some, all, or none of these cities, how many travel options does she have? So what we do first of all is count how many elements or how many cities you have. And let me see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 11 cities that she would like to visit. So that means n is equal to 11. All right, and when they're asking you to figure out how many travel options, they want to know how many subsets. So we're going to go 2 to the nth power to get your number of subsets options. So in this case, 2 to the 11th power, and again, we'll use our lovely calculator, and you'll get 2,048 travel options. So if she wants to figure out a way to visit all 11 cities, she has 2,048 different travel options. That's amazing. So this problem is too similar to the previous problem, so I'm going to change it just a little bit. It says how many different groups of students can show up for a seminar with an enrollment of, and I'm going to say 13, with an enrollment of 13. How many different groups of students can show up for a seminar? So remember, you're thinking of your subsets, because remember, you can think of, it could be all the students, none of the students, or some of the students that show up for the seminar. So we're looking at subsets once again. We're going to say n is equal to the enrollment of 13. So I need to find 2 to the n power. And if you were to put this in your calculator, you should get 8,192 different groups. So 8,192 different groups could possibly be made if 13 students are enrolled. This concludes the lecture for 2.2.